Hello everyone, welcome to my YouTube channel Practical AI by Ramsri, and today we are going to see another interesting video on deploying question answering model of HuggingFace transformers as an AWS Lambda container image. And of course it will infer some cost because we are not going to do completely serverlessly, because since there is a little bit of cold start, we are going to give provision concurrency, but still it can scale, and also it's at the order of $35 for provision concurrency, so not a bad option to deploy it that way. Anyways, let's see how we are going to do it in 3 simple steps. So step 1 is we are going to use AWS CLI. CLI stands for command line interface, and we are going to install AWS CLI and we are going to configure so that everything points to our AWS account. Secondly, we are going to use AWS SAM, serverless application model, and the biggest advantage with AWS SAM is that from the command line interface itself you can deploy a Lambda container image and also get API endpoint, and you can attach anything like DynamoDB database, etc. So everything can be done from command line, so you can deploy and get a final ready to use API with AWS SAM. There's a little bit of configuration and learning curve that you need to go through, but once you get used to this, you'll feel that using AWS SAM is kind of a breeze and eases out on quite a lot of tasks. For example, if you're deploying, normally you would have Lambda, then there is API gateway attached, then you might need some storage with DynamoDB. All of that can be configured in SAM easily because it has templates that you can begin with, and that essentially is step 2, where we modify the AWS SAM template. We'll start with a basic template of container image, and then we'll modify that according to what we want, which is essentially doing question answering with HuggingFace, and we will deploy that. The third and final step is, once you deploy the model, you can do the inference, but it's serverless inference. What that means is that every time your API hits, then only container is loaded onto AWS Lambda environment, and then the inference is done. Usually this has lag of 10 to 15 seconds, etc. sometimes. So if you are deploying production apps and you don't want to have this kind of latency, you can avoid cold start by actually giving provision concurrency. What that simply means is that you can give a number like 1 or 2 and just tell Lambda to be always warm, whether it is 1 instance or 2 instances, how many ever that you want. So whatever the number that you give in provision concurrency is what AWS Lambda uses to keep that many concurrent invocations warm and always ready. So you can avoid cold start altogether, and you can completely use it in production for real-time inference. Awesome. We are going to next see that. Let's go. Awesome. Let's get started. So first you can just type AWS CLI in Google, and you will get to this link, AWS command line interface. All you need to do is just follow it for your operating system, and then just install AWS CLI. And once you're done with that, just do the same thing, which is AWS SAM CLI, and follow the instructions for your operating system, and then install SAM CLI. And once you're done with that, simply go and open your Windows or whatever operating system that you're on terminal, and just type AWS configure. And here I've already given access key ID, but essentially you can go to your AWS management console and go to IAM, identity and management service. You can come here and you can create a user here. You can create a user here, username, and give them programmatic access. So programmatic access creates a access key and secret key for you, and give the highest level of permissions if you're the only one using, or if you are giving it to other, then make sure that permissions include access to API gateway, Lambda, and other deployment things as necessary. But I've done that already. So simply what you see here, when you click on AWS configure, if you're doing it for the first time, give that access key ID, secret key ID, then default region, and the output format as well. And once you're done with this, let's do SAM init. So what we are doing now is to start with a AWS SAM template so that we can deploy everything. So when I do SAM init, it asks which template source would you like to use. I'm clicking on quick start templates, then zip and image. So essentially, do you want to deploy it as a zip or use container image? I'm using container image. If you have small things like NLTK, etc., you can use zip, but here I'm using HuggingFace and PyTorch, so I'm going to use container image. And now you can pick the base that you want. For example, I am choosing Amazon Python 3.8 base, so 4, and give a name for the app. I would say I'm doing this for question app, so question answering Lambda, and it will create a template for you, starter template for you. Now you can pick which one do you want, PyTorch, machine learning, or Hello World. Let's start with Hello World itself and modify everything. Awesome. Now the template is created. Let's go have a look at the template. So I've just opened everything in my text editor, Sublime Text, question answering Lambda, and you can see that template.yaml is the YAML file that is already created, and it's a Docker file, etc. And the main code is in Hello World, where the app.py and Docker file and requirements.txt are stored. Now we are going to edit all of these things to create the question answering model and see how we can deploy this. So we'll start with the template.yaml file and proceed ahead. So first of all, the function timeout here is 3 seconds. So let's change that to 29 seconds. And there's a default memory that Lambda uses. So I'm just changing that to 3 gigabytes, etc. And why are we doing that is once we package our container with HuggingFace and PyTorch and necessary things for question answering, the base image is going to be at least 2 GB or more. So to have enough size, we are creating this. So the timeout for the function is 29 seconds and memory size is 3008, so approximately like 3 GB. And then let's change the path to Hello World to some name like question answering, and we are going to change the method from get to post, because you will see in a bit how we call with a post request sending all the contexts and questions and getting the answers back. And let's also change hello to question answering here. So what this is going to do is to automatically deploy it as an API for us and give the link directly. Great, we are done with the changes in the template.yaml file. Let's save this. Now let's go to requirements.txt. So in the requirements.txt, I'm going to add few more things. So the first thing is I'm installing Torch, PyTorch, and installing transformers because we need both of these things for our question answering API. And let's get to the app.py file. Let's delete this to get started. And what I've done here is to include another file called as local_download.py. And why did I do that? You'll see that in 1 second. So essentially we are using this model from transformers, HuggingFace transformers called deepset/roberta base squad 2 for question answering. And because of this, if you want to package the container to include this model, first we need to download the model locally and then package it along with this. That's why I have this code which downloads the model into this folder roberta base squad 2 that's created once we run this. So let's just go to our command line and run this. So in order to be able to run this, you need to have transformers and PyTorch installed. So I've created an environment already that can run this. Activate question is a conda environment that I've created to be able to run this. So I'm just running now python 3 local download.py. Okay, sorry, python local download.py. And if you see, you'll notice that there is a new folder that is created and it has all the PyTorch model and all the tokenizers saved. So everything was taken care by this code that we just ran. So local download downloads this folder here. Now the next thing to do is actually go to the Docker file. We don't need to do many changes to this Docker file. Everything looks good. All we need to do is just add another line here, which is copy roberta base squad 2 to this OPT ML model. This is the path that Lambda uses and it's within the local file directory of AWS Lambda. That's why we are using this path. So essentially this is copied onto here. That's what you need to remember. So when Docker image is being created, the local roberta base squad 2 folder is also put onto this path. And now the Docker file is complete. Let's go back to app.py. Now in app.py, let's change these imports and add few more. So basically we are getting Torch and transformers pipeline. Pipeline fastens the process where we can just give the question answering tag to this. And we are pointing the model and tokenizer path to where we have our model, where we copied our model in Docker file. That's all this is doing. Now let's add some more code here. So essentially what we are doing here is, since it is a post request, we are getting the text from the post request whatever we want to run question answering on, and we are passing that text to the NLP pipeline object that we created, and we are finally returning the output here. Perhaps we don't need this, so let's make it even simpler. All you are doing is creating the final output as a key value object dictionary, and then we are returning that. So in order to return that, let's modify this to just json.dumps final. So essentially that's what you have here. So this is all the code that is necessary. Now that we are here, let's go back to our main folder, question answering Lambda, and just do sam build. We have all the code ready. So as you can see, the build will go through some steps here. Now we are done with the build. One thing to remember is that you need to have Docker installed on your local system where you are running this, because all this requires Docker. And you can see that I have Docker up and running. Let's see the images. As you can see, less than a minute ago, something of 2 GB size is created. And let's do this. So sam start local API. So what this does is, it is actually sam local start API. What this does is that it starts a local API so that we can start testing whether the API is working or not before even deploying it on production on real AWS Lambda. Let's go ahead and use another tool. Okay, we can see that the API is live at localhost 3000. So I'm using a tool called as Postman. You can download the tool and install it on your system. So essentially at localhost 3000 / question answering, this is the path, because in our template.yaml we have given this path question answering. So that's the path, and body and headers is content type JSON, and the request is post. As you can see, I've created a small list of question and answer pairs, 2 question and answers pairs, who has shown that they can influence the digital currency market. Elon Musk has shown he can influence. Who is going to college? Ramsri is going to college. So there is context and question. It is supposed to extract answer. Let's just click on send and see. Okay, the first it took quite a lot of time, 44 seconds, but you can see that the correct answer is extracted, Elon Musk and Ramsri. The only thing is that there is quite a lot of on local system you need to bring up the Docker container and everything, so there's little bit of lag, but you will soon see that once we deploy it on the cloud, we can give provision concurrency and essentially get this to 1 second or 2 second or even sub-millisecond inference. So don't worry about this, we are going to fix this, but essentially you can see that we can change anything and get back the correct answer, and this API is working on the local system, so that's great. Now let's stop the local API and let's get on to the final part where we deploy this on AWS Lambda. So now just do sam deploy guided. Do guided only for the first time because we need to establish quite a lot of things. So give a name, question answering, region. So it asks for image repository for this function. So go to your AWS console. Go to your AWS console and search for ECR, Elastic Container Registry. Once you're on there, click on Get Started and create a private repository. For example, question answering, and just click on Create Repository, and you can see that this is the repository in Elastic Container Registry. So what essentially happening, what's happening is that the Docker image will be stored in here and it will be pulled from here for Lambda deployment. So essentially this is the container repository for the Docker image. So copy this URI and then paste it here in the image repository for hello world function. Confirm changes, yes for everything. Yes for everything. Now you can see that the image is being pushed onto this repository. We are finally done with the task, and let's go to our Postman and let's create a copy of this. And now instead of local, just change it to AWS, and I'm storing it in the same place. Now the biggest thing that you need to do is, we have created a copy of the local one, and you can see this is the API URL. Just copy that, and instead of this, enter that and run this, which now runs on the AWS Cloud Lambda function. And the first time when you run this, you might even get a timeout error because the system is warming up and there is cold start at the moment. We are going to fix that, but first make sure that everything runs. So even if it takes a little bit and you get a timeout for the first time, click on send again, and yeah, as you can see, endpoint request timed out. Anyways, let's run it again. Great. After almost 2 timeouts, we are able to run this. But let's go ahead and immediately fix what we can do to not get this cold start at all. Let's go to our AWS Lambda console and let's go to Lambda. Identify the Lambda function that you deployed. So mine is just 3 minutes ago. This is the one. So let's click on that. So once you click on that, you have actions here. Go to actions and create alias. Cancel. So once you go to the Lambda function, go to actions here and click on publish new version. So whatever version which is currently $latest is going to be deployed as version 1. You don't need to give anything here, just click on publish. And you'll see that we have created version 1. Now go to actions and create alias and give a name as live. and live is attached to version 1, you cannot you can create an alias for latest, but what we are going to do is use version 1 or whichever version you deploy, because you will see that when we give provision concurrency, you cannot give an alias that points to latest. It has to point to some version. So essentially give live here and version 1 here and click on save. So now what you need to understand is that this alias of live points to version 1, and you know that this is the function ARN. Copy that. Copy this function ARN right here. Go to services and go to API gateway. It looks a little roundabout in the initial phases, but don't worry. If you just do it multiple times, it becomes easier for you. And why we are doing this is so that we don't have cold start. We can give provisioned concurrency. Again, in the APIs, identify the most recent one. So if you just click on created, you can sort out the first one, the most recent one. So go on there and click on the post method, and within the post method click on integration request. So the simple thing is that right now this Lambda function points to this path, which always points to latest, but rather we want to give the function URN and point it to live. That's what we want to do. Click on OK, and once you're done, click on deploy API and click on prod deploy. Okay, great. Everything is deployed. Now let's go back to our Lambda. And within Lambda, select our function again. Now go to configuration and click on concurrency here and provision concurrency. So first time, if you don't have 1000 or any high number of provision concurrency, request for additional provision concurrency, and it will take a day or two for you to be approved. Why I'm saying that is, once you click on add provision concurrency and choose the alias here, choose the alias of live, and 900 is available here for provision concurrency, and I'm giving 1. So that means that one machine is always up and ready without cold start. Now click on save. If you don't have number, if it doesn't let you give any provision concurrency, request for additional provision concurrency given your US East 2 or whatever region that you are in. Remember to do that. And right now it's just deploying. Just click on refresh. Just wait for a couple of more minutes so that this will be ready. And once it is ready, you can go on to your Postman and run the request again and see that there is no cold start. Awesome. Finally, you can see that the status is ready. Let's go back to our Postman and run it again. And this time you can see that in about 2.5 seconds we got the output. But let's just confirm that there is no caching or anything. So instead of Elon Musk, give Bill Gates, and instead of college, give school, and yeah, instead of Ramsri, let's say some James, etc. Just click on run. Awesome. In about 500 milliseconds, so that's 0.5 seconds, we got our correct answer, Bill Gates and James. So you can see how we have deployed AWS on AWS Lambda question answering model from HuggingFace, and for about $32, as you could see, about $35 or so monthly cost. You can have this always warmed up with provisioned concurrency ready to run. This is inexpensive when compared to other deployments. Most other deployments cost money. So this is how you can use AWS Lambda and deploy a question answering model for your use case and production ready with no cold start. Thanks for watching, and if you loved the content, please subscribe to the YouTube channel.